Okay, so Bacho, we were talking about chapter number 1, which is actually states of matter. You can see over here, Bacho, we already did what state this distinguished properties of solid, liquid, and gas. This is your syllabus you already did, right? Then describe the structure of solid, liquid, and gas in terms of separation, arrangement, motion, right? You already did this. Then melting, boiling, evaporation, freezing, condensing. You already aware about these terms, and we did heating and cooling curve as well, right? And we already know that what happened when we apply temperature, but we don't discuss about the volume, right? So we will start with this today, inshallah. Then we are going to end this chapter, right? First of all, I just want to start with diffusion, right? So I am starting with diffusion, and then at the end of diffusion, I will explain this point to you, right? It is very simple. Okay, so let's start with diffusion. Right over here, what is diffusion, Bacho? Any one of you want to explain the word diffusion? So kind of tell me.
Movement of air concentration with the movement of lower concentration gradient is known as diffusion.
Yes, very good, very good. Yes, so Bacho, we know that it is actually the movement of molecules. It is actually the spreading of the molecules from higher concentration to the lower concentration. It is why the particles doing this type of phenomena, why they are doing this now. Just think about you. For example, if you are in a very crowded area, right? For example, if you are in a very crowded area, so you feel that you need to shift yourself towards something which is less crowded area, right, Bacho? Everyone want stability, na? Everyone want like there should be something less crowded area, na? Sometime, for example, if someone want to sleep, right? So in a very crowded house, we cannot easily sleep with a soothing sleep, right? Definitely for this, we want our rooms that are having only a 1% or 2% where we can rest, we can sleep, right? So everyone want stability, everyone want to move towards something less crowded, right? Same as it is, the particle do this. For example, in your houses, in the kitchen, your mother is going to cook the biryani, right? So the biryani molecule, the smell of biryani molecules are just crowded in the kitchen, right? A lot of biryani molecules are over there, the smell of biryani, right? So they just want to move on from there towards the less crowded area, right? So that is why you are sitting in your drawing room, you are sitting in your bedroom, the smell of your the biryani molecules are coming towards you, because in your room or in your drawing room, you can see this, there is a less crowded area of biryani molecules. So they just come over here and you just feel कि यार आज biryani ban rahi hai ghar mein, right बच्चों? So this is all about the molecules, why they are moving from higher concentration to lower concentration. They are just moving from higher crowded area towards the less crowded area, right? For example, आप किसी एक industry में काम करते हैं, and in that industry, a lot of people are skillful like you. For example, the skill that you have already, all the staff member over that industry having the same skills, right? So you are feeling यार यहाँ तो सब मेरे जैसे हैं, right? तो मुझे यहाँ से निकलकर किसी ऐसी जगह जाना चाहिए जहाँ मेरी अहमियत हो, right बच्चों? Is that clear? So why you are moving from a higher crowded area towards lower crowded area? Is that clear? Yes, बच्चों. So this is what diffusion means. This is what diffusion means. The particles, the gaseous particles, are start moving from higher concentration to lower concentration. They are moving towards higher concentration to lower concentration of that molecules, right? We are talking about a spatial molecule right now. Just for example, you are using the perfume, right? So in the perfume bottle, you have a lot of crowded area of perfume molecules. Now you just spray that on your shirt, and on that shirt you have the crowded area of molecule that you sprayed, right? And then from that crowded area, the molecules of the perfume are going to spread out. They are just moving towards where they are lower in concentration, and specifically the lower in concentration of perfume molecules, right? Is that clear? So
yes, sir.
So you can simply say that it is actually the spreading of the molecule. It is actually the spreading of the molecules from higher concentration to lower concentration, higher concentration to lower concentration. Right, bacho? So this is what the definition of diffusion is. Diffusion can be happen in solids, it can be happen in liquids, it can be happen in gases. As the particle in gases are far apart from each other, so they will show the greater diffusion side, right? Because the particles are far apart from each other, so they can move very rapidly. That is why the diffusion occur in gases is fast, right? That is why most of the time we talk about the gaseous diffusion. Even the diffusion can occur in liquid and it can occur in solid as well. But most of the time we just talk about diffusion in gases. Right now you can see this diagram. In this diagram over here, you have bromine molecules, right? This is bromine molecules and this is air, right? You can see this in this jar. You can see this. It is a crowded jar with bromine molecules. A lot of bromine molecules are here, right? Once you remove the lid between these, just remove the lid. After a few minutes, you will see that all the molecules of bromine start moving upward, because in the upper jar there is less concentration of bromine molecules, right? And after 30 minutes or 40 minutes, you will see that the whole two jars are going to be having same color. And you can see over here, this is showing you the mixing up of molecules, right? So you can say that the bromine molecules take spaces between the molecules of air. So it is actually random spreading of the molecules in the spaces where they are not present, right, bacho?
Yes.
Then if you talk about spatially you are talking about the diffusion of gases. When you talk about diffusion of gases, so actually there are two factors on which the diffusion of gases can depend, right? One is molecular mass of the gas and the second is the temperature, right? Second is the temperature, right, bacho? So if you talk about the molecular weight, so it is very simple for you. You all know that if something is very heavier in mass, so definitely it can run slowly, right? The one which is lower in mass can run fastly. For example, agar main aapse kahun, you have one elephant and you have one rabbit, and we are going to compare the speed of these two, right? So which animal's speed is faster, a rabbit or an elephant?
Sir Rabbit.
Rabbit is fast because it is lower in mass. So you need to keep remember the gas which is lower in mass can diffuse faster, right? You need to remember this point. It is very, very important point of this topic, that gases with lower molecular mass can diffuse faster. Okay, bacho, can diffuse faster. And if you talk about temperature, so temperature is just like this. You know that when you heat something, so the kinetic energy of the particle is going to be increased. So it is going to be moving faster. So temperature is directly proportional to the diffusion. So it's very simple. If you are increasing the heat, so the kinetic energy of the particle are going to be increased and the movement of the particle is going to be increased. So you can say that gases at higher temperature, diffuse fast, right? Diffuse fast or faster, can diffuse faster, right, bacho? Is that right?
Yes, sir.
Now we have one more example over here for this. For example, this is a cotton wool. This is a cotton wool. This is soaked with HCl. Soaked with HCl. बेटा अपना माइक म्यूट कर लें जिसका भी खुला हुआ है. And we have one more cotton wool that is soaked with ammonia gas, right? So they are asking that something is going to be formed over here, and it is what it is. For example, when NH3 is going to react with HCl, so they are going to be form ammonium chloride, which is having a dense cloud which is forming over here. So the question is why the dense cloud is forming near ammonia and away from HCl. This is the question. Why the formation of ammonium chloride cloud, dense cloud, is forming away from hydrochloric acid and near to ammonia? So it is simple. You can see over here, bacho, that ammonia, a gas ammonia over here, it is NH3. So we know that from the periodic table, we can find out the MR of this gas. And for example, if you talk about nitrogen, so each nitrogen having 14 MR, right? And each hydrogen having 1 MR, right? So it is multiplied by 3 because we have 3 hydrogens right now. So the molecular mass of ammonia is 17, right? And if you talk about HCl, so each hydrogen having atomic mass of 1 and each chlorine having atomic mass of 35.5. So if you focus about HCl, so it is 36.5, right? So you can see, bacho, over here, the heavier gas is HCl. HCl is heavier and ammonia is lighter. So you can say that ammonia being lighter, diffuse faster, being lighter, diffuse faster, and travel greater distance. Right, bacho? Is that right?
Yes, sir.
सर लेकिन यहाँ पे अमोनिया तो कम डिस्टेंस ट्रैवल कर रहा है और HCl ज्यादा कर रहा है.
Oh, yes, you are right. But by mistake, I write ammonia over here and HCl over here. Thank you. This is HCl and this is ammonia, right? Thank you. Okay, so this is actually the mistake by me over here. You can see this ammonia is the lighter gas, so it can diffuse faster and it can travel more distance, right? So over here, ammonia diffusing greater over here, and HCl is moving lower because it is having a lesser distance because it is heavier, so it will take time to reach to the center, right? So that is why before reaching HCl towards the center, ammonia reaches towards HCl and they just combine together and forming ammonium chloride, right, bacho? So that is why this is going to be happen towards HCl. अब ये जो आपके पास ammonium chloride का जो cloud बना है, it is nearly towards HCl, right? One more example we have about this is this structure. This is a very basic structure which is not present in our books as well, right? And a lot of MCQs, a lot of questions are in past papers about this structure that you need to understand, right? Over here, this is a porous part. They are saying this part is porous, right? It means the holes are over there on this part, and they are saying that we have a gas inside that, and inside the gas is carbon monoxide. They are saying that we have a gas inside which is carbon monoxide. This is carbon monoxide, right? Carbon monoxide. And they are saying that we have the other beaker which is inverted on this, and this beaker is filled with the next gas, which is actually right now we have which gas? This is nitrogen gas, N2, right? You can see this, bacho, that N2 is having actually 14 plus 14, it is having 28 MR, right? And if you talk about carbon monoxide, so it is carbon monoxide is 12 plus 16, it is 28 MR, right? So both the gases are having the same MR, right? So for example, if any gas or any molecule of nitrogen is diffusing inside any gas or any molecule of nitrogen is like diffusing inside. So there is no net pressure on the level of water, right? The pressure will remain same because the mass of carbon monoxide and the mass of nitrogen is same. So there is no overall effect on the pressure of this liquid. So this level of water remain constant, right? So you need to understand this. For example, the outer gas was lighter. For example, the outer gas was lighter, so it will diffuse quickly inside. And when it's diffused inside, it will apply pressure over here, and then the level of the water will rise, right? This is the very important point about this experiment that you need to understand. If you have the same gases outside the porous beaker or inside the porous beaker, if the gases are same with the same MR, right? So there is no net effect on the level of water because the masses are same. If even the nitrogen gas is diffusing inside, or even the carbon monoxide diffusing outside, both the gases are same. So the masses of both the gases are same. So there is no effect or no further pressure that is going to be applied on the liquids. That is why the level of the water is not changing. It is constant. But if the gas outside the porous beaker is lighter, so it will diffuse faster inside. When it diffuses faster, so it will apply pressure. The molecule of gases are just accumulate inside the beaker, so they will apply the pressure over the liquid, right? Then the level of the water will increase, right, बच्चों?
सर तो जब इक्वल मासेस हैं तो अब डिफ्यूजन हो रही है बट प्रेशर जो वाटर लेवल है ये राइज नहीं करेगा.
Exactly, you need to understand this. If the MR of both gases, if the MR of both gases are same, then there is no change in the level of liquid, right? There is no change in the level of liquid, right, बच्चों?
Yes.
Even the diffusion is going to be occur over there, that's not making a difference over there, right? So for example, if we have one more question over here for you, so what is going to be happen with this? For example, if we have different gases, we have like right now we have hydrogen gas, for example, we have ammonia gas, right? For example, we have methane gas, for example, we have nitrogen gas, for example, carbon dioxide gas, chlorine gas, HCl gas, sulfur dioxide gas, sulfur trioxide gas, nitrogen dioxide gas, H2S gas. We have these different gases over here. For example, a lot of gases are over here. So we know that hydrogen atomic mass is 1, so it has 2. The molecular mass of this is 2. And if you talk about nitrogen, so it is 14. Each hydrogen is 1, so it is 17, the MR. Carbon is 12, and each carbon is 1. Sorry, each hydrogen is 1, so it is giving you 16, right? Then nitrogen is 14. Each nitrogen is 14, so 2 nitrogen will give you 28. Each carbon is 12, and each oxygen is 16, so it will give you 44, right? Chlorine is 35.5, and if you have 2 chlorine, so it will be 71, right? H is 1, Cl is 35.5, so it will give you 36.5, right? Same as it is if you talk about sulfur, so it is 32, oxygen is 16 into 2, so it will give you 64, right? Sulfur is 32, oxygen is 16 into 3, it will give you 80, right? Nitrogen is 14, oxygen is 16 into 2, 16 into 2, it will give you 46. Then hydrogen is 1, right? And sulfur is 32, it will give you 34. So you can see this, these gases having different molecular masses, right? And if we arrange them on the basis of diffusion, rate of diffusion, that how they are diffusing, which one is going to be diffused first and which one is going to be diffused later on, or you can say that which one is going to be diffused faster and which one is going to be diffused slower. So we can arrange that like this. The fastest is hydrogen, the fastest, because it has a lower molecular mass. So the fastest gas that can diffuse is hydrogen. then we have methane, then we have ammonia, right? And after these gases, we have like nitrogen gas, and after nitrogen we have H2S gas, right? And after this we will have HCl gas, right? And after HCl we will have carbon dioxide gas, then we have NO2 gas, right? And after this we have sulfur dioxide, and then we have sulfur trioxide. So you can say that this is the fastest to slowest rate of diffusion, right, bacho?
Yes, sir.
Is there any problem with any one of you?
No, sir.
सर आपने क्लोरीन
Okay.
गैस नहीं लिखी?
क्लोरीन गैस नहीं लिखी, 71 पर है ना, तो हम इसको लिख सकते हैं यहाँ पर, राइट? ओके, okay, so for example, if I have a question with you guys, so can you solve this question? The question is, for example, state and explain. State and explain why chlorine gas diffuse faster than faster than sulfur trioxide gas, right? Yes, but so you need to solve this and send me the answers. You need to state and explain. It is for 2 marks, right? So you need to give a reason as well, right? Jaldi se isko solve karke mujhe about other things. So over here, bacho, for example, if we have 2 different gases, example number 3 or example number, whatever the example number, you don't care. For example, we have neon gas at 20 degrees centigrade, and we have chlorine gas at 40 degrees centigrade. So which gas will diffuse faster? Just look at over here. Neon gas having the MR of 20, right? And chlorine gas having MR of 71. And even the temperature is high over here, but chlorine is heavier gas, so it will diffuse slower. Neon will be going to diffuse faster, right? Because neon being lighter will diffuse faster, right, bacho? And for example, if chlorine at 20 degrees centigrade and chlorine at 40 degrees centigrade, so you need to write then now chlorine gas at 40 degrees centigrade will diffuse faster due to the greater energy, right? Due to the greater kinetic energy at higher temperature, right, bacho? Is that clear to all of you?
So एक बार फिर समझा दें.
This is simple, bete. If you have 2 gases that they have different molecular masses, now you can see this. It is lighter and this is very heavier, right? So, agar temperature iska double B hai, so it does not matter because lighter gas ज़्यादा अच्छे से diffuse करेगी, fast diffuse करेगी, क्योंकि वो lighter है. अगर दोनों gases same हो और temperature different हो, so you need to understand this. We already learned the factor of temperature on gases. When we increase the temperature, the kinetic energy of the particle increase, and then they move with faster kinetic energy. That is why chlorine at 40 degrees centigrade, it is a higher temperature, so it will diffuse faster, right?
So we have to write both of the statements, right?
No, this is a different question, and this is a different question.
ठीक है sir.
Right? Neon और जो आपके पास chlorine है, वो दोनों अलग अलग गैसेस हैं, तो उसको हमने अलग अलग कंपेयर किया है. और यहाँ दोनों, यहाँ ये जो केस है, ये सेकंड केस है, ये फर्स्ट केस है, राइट?
सर नियॉन और क्लोरीन वाला क्लियर नहीं है।
नियॉन लाइटर है ना, अभी तो किया है आपने। नियॉन का मॉलिक्यूलर मास कितना है 20 और क्लोरीन का कितना है 71। इतना ज्यादा डिफरेंस है
सर लेकिन
मॉलिक्यूलर मास।
टेम्परेचर तो क्लोरीन का ज्यादा है।
हाँ टेम्परेचर क्लोरीन का ज्यादा है ना, बट देखें अगर फॉर एग्जांपल अगर आप ऐसे भी देखते हैं, अगर आप कंपेयर करते हैं तो अगर फॉर एग्जांपल क्लोरीन 40 होती, अगर क्लोरीन 40 होती तो चलो समझ में आता कि दोनों ये डबल है। आप देखो ये डबल से भी ज्यादा है, ये 3 टाइम्स से भी ज्यादा है, एटलीस्ट इट इज 3.5 टाइम्स ग्रेटर, है ना।
सोचिए हम लोग कैसे मतलब अंदाजा लगा सकते हैं कि कैसे
आपको अंदाजा
मतलब
आपको अंदाजा ऐसे लगाना है, जब कभी भी आपके पास टेम्परेचर और मॉलिक्यूलर वेट दोनों आ जाएंगे तो आप प्रेफरेंस देंगे मॉलिक्यूलर वेट, राइट।
सर मतलब टेम्परेचर इग्नोर करेंगे उस सिनेरियो में।
Exactly. You need to prefer the molecular weight first, right? और फिर वो इतना ज्यादा एक्सेस टेम्परेचर आपको देंगे भी नहीं जिसकी वजह से इफेक्ट आएगा डिफ्यूजन में। डेफिनेटली वो थोड़ा सा इंक्रीज करके देते हैं, जैसे 20-25 दे देते हैं, 20-30 दे देते हैं, 20-40 दे देते हैं, दैट्स मैक्स। इससे ज्यादा टेम्परेचर इंक्रीज करेंगे तो मैक्स हो सकता है शायद डिफ्यूजन में डिफरेंस आ जाए, बट राइट नाउ we don't need to consider this. We just need to understand this thing, that molecular weight is the preferable thing that you need to understand, right? In diffusion. Okay. Okay, bachcho. Is that clear?
जी सर।
जी सर।
Okay, so the last point of this chapter, that the syllabus number 5, SLO number 5, that they are saying the effect of temperature and pressure on volumes. The effect of temperature and pressure on volume. So it is very simple for gases, bacho. It is very simple. If you increase temperature, bacho, so the volume is going to be increased, right? If you increase temperature, so the volume of the gases is going to be increased, right? And if you increase pressure, agar aap pressure badhate ho, so we know that when we apply pressure on the balloons, so the volume of the gas decreases, right? You need to understand this. If you increase the temperature, so definitely the volume of the gases increases, and if you increase the pressure on the gases, so the volume of the gases decreases, right, bacho?
Yes, yes.
So this is very simple thing. If you talk about the example of this, bacho, so the example will be like this. For example, if you have chlorine gas, right? If you have chlorine gas, so at 20 degrees centigrade and at 40 degrees centigrade, you need to keep remember the same amount of chlorine gas. For example, if you have 1 mole, or if you have, for example, any amount of chlorine, right? So I'm not using the word of amount right now over here, not even volume, not even mass, not even moles. So I'm just telling you that the volume of the gas is different over here with the same mass. So at 20 degrees centigrade, it is, for example, considering this space, itni space occupy kar raha hai. So at 40 degrees centigrade, the space occupied by the gases will be increased, right? Right, bacho?
Yes sir. So sir इसका मतलब है टेम्परेचर वॉल्यूम डायरेक्टली प्रोपोर्शनल, प्रेशर वॉल्यूम इनवर्सली है।
Exactly. For example, if you have atmospheric pressure, which is the normal pressure, right? It is, for example, atmospheric pressure. So at atmospheric pressure, for example, the size of the balloon or anything like any gas like this. This is the size of any balloon or any container having the gas, right? If you twice the atmospheric pressure, if you increasing the pressure, so the size will be going to decrease, right? This is a thing that you need to understand. If you increase temperature, the volume, the space occupied by the gases are going to be increased, and if you increase pressure, so the space occupied by the gases will going to be decreased. All right, bacho?
Yes, sir.
Is that clear to every one of you?
Yes sir.
Okay, so this is all about this chapter that you need to understand. Inshallah, in the next class, we will do some past papers of this, right?